Okay, so in the previous video, I told you that I will now move to the source drain epitaxy, but I have found that the source drain epitaxy is quite complicated because we have to control the directional growth to consider the shape of a grown source drain region. Well, in this video, I just wanted to share the difficulty of current implementation. For that purpose, I have introduced another example underscore sphere. So in this case, we make just an empty space and uh, by using a special routine, just to draw one pixel, one voxel at the uh, position of 51, 51, and 101. This is corresponding to the center of the entire simulation domain, and its material is uh, recognized as the silicon material. After that, after saving this initial dot, and I just called uh, isotropic deposition, and it is done with 30 steps. So if it is really the isotropic deposition, then what I expect is having a sphere whose radius is 30 uh, in this scale. However, as we all of us know, that is not the case because in this case, in this implementation, the directional growth is only along x direction, y direction, and z direction. So we have a little bit uh, difference from the ideal sphere. Um, okay, so let's just have a look at the result. So I just run it. So it is quite fast because this is a little trivial. First, uh, load initial dot cgns file. Then okay, it is difficult to see it quite clearly, even when I introduce color. Uh, it is difficult, but you can see that there is one single dot at the center of our simulation domain. After that, I just call to make an isotropic deposition. So what I expect is the growth of this point. So I just load radius 30, and when we load it, so now we can find that this is the case of growth. So now you can see that this is not the sphere at all, because here we have a major axis x and y and z. So the distance between this origin, the single point, and this point is 30, I guess. It's good, but here we don't have any kind of circular shape, so their difference is completely different. So what we can say is the current implementation of our depot underscore ISO is far from the realistic isotropic deposition. So that's the problem because in order to make a source and drain epitaxy, we must control the directional growth rate. However, even the simplest one, isotropic one, is not easy to be implemented in this voxel-based implementation. So, well, now mm, of course, even previously I understood the problem, but now it becomes more and more important. So I have to solve that problem. So when I solve that problem, I will come back to you and show the improved result. Thank you.